Please watch this video.
Nu ska jag visa två väldigt användbara begrepp.
I will now show two very useful concepts related to soil water storage: field capacity and wilting point. Field capacity tells how much water a soil can retain against the effect of gravity, and wilting point gives how much water is left when the plants have sucked as much water they can for their transpiration. This is a sponge that we can regard as a soil. It has very high porosity and it has also a good ability to retain water. I'm now raining on this soil, a pretty big rainfall.
Ganska mycket stort regn kommer här. Men allt det här,
All this infiltrated water is stored in the soil, and we can see it as it is stored in the upper part of the unsaturated zone, the root zone.
markvattenzonen. Fortsätter att regna.
The rain continues, still all water is stored. It becomes wetter, of course, and heavier.
Den blir blötare och blötare förstås, lite tyngre. Nu.
Now the dripping starts, and after a while the dripping stops.
Och efter en liten stund så slutar det droppa här.
Now we say that the soil is at field capacity, the maximum water content that can be held against gravity.
Mot gravitationens inverkan. Om jag nu
Further rainfall on the soil will now result in outflow of the same amount.
så att jorden är laddad kan
We can say that the soil is loaded.
göra att
Rainfall on such soil would give percolation of water towards the groundwater.
det som vi hör här nere kan vi säga. Det är
What we can see and hear now is the groundwater recharge.
Sen, när
When the
regnet
rainfall
slutar så
stops,
håller
the soil keeps this water content. The plants can use a part of that water while waiting for the next rainfall.
i väntan på nästa.
They are developing a negative pressure to suck the water.
Suger ut vattnet.
I cannot create a suction, but we can say that this water is what is taken up by the plants.
Växterna som
It should of course have gone upwards.
suger ut det skulle egentligen gå.
Eventually the pressure of the remaining water is so negative,
Men
the
så
water is so
småningom
tightly bound to the soil, that the plants
vattnet
cannot
så
suck any more
mycket
water.
att växterna inte längre kan suga.
Then the soil moisture is at
De
wilting
kommer till
point.
gränsgränsen.
There is some water left, mainly bound by adsorption,
Främst
but it cannot be used by the plants.
och det kan inte
The water we just saw falling down is the plant available water
ramla
that the
ner
plant
här.
can take up and send to the atmosphere.
Som växterna tar upp och transpirerar.
I'm wetting this soil once more.
Jag väter upp
The
den här
water
gången
infiltrates,
lite snabbare.
increases the soil moisture content, and eventually reaches field capacity.
Vattnet infiltrerar, höjer markvattenhalten. Och så småningom uppnår den fältkapaciteten.
Now,
Börjar droppa lite ur den.
some extra water will give abundant dripping.
Vatten här, så det droppar ordentligt.
Then I turn the soil,
Via jorden.
and now the dripping stops.
Och då slutar det droppa på en gång.
If I raise
Ställer
it,
den så här.
the dripping starts.
Så ska vi se om det börjar droppa. Ja. Då droppar det ur den.
It seems as if the field capacity depends on the orientation of the sponge. When standing, it can retain less water than when lying.
Och det beror på att
For water to leave the sponge, the pressure of water at the bottom has to be equal to that of the atmosphere.
atmosfärstrycket här i underkanten. Jag kan
I'm now wetting it in a lying position.
väta den på den här ledden den här gången. Tills det börjar droppa ur den.
Now it's dripping. It is now at field capacity. The water has atmospheric pressure at the bottom, and we can call it the groundwater surface. The pressure of water above equals the distance to the water table. At the top, about 2 centimeters above the water table, the pressure is about -2 centimeters. This is the most negative water pressure of any pore in the sponge now. But if I turn the sponge, a lot of water is drained, and it corresponds to the water in some of the pores in the upper part, where the pores are exposed to a pressure of about -10 centimeters, making also the somewhat smaller pores to be emptied.
Okay, I think it gives you a very good understanding about the concept of field capacity and wilting point. Let's see, there is another video to show you.
Okay, in this video, I'm just going to really quickly show you how to take an area.
No, that's not relevant. Okay, we'll go back to the presentation. All right, now we'll move further. Now this I have quoted out from the course material. Now these are the definitions of each zone. There is a zone called saturation zone. That is at the saturation moisture content. Then the zone 2, which is beneath the saturation zone, is called transition zone, and this zone 3 is called transmission zone. Now if you read it out, the next lower zone is the transmission zone, where the downward motion of the soil moisture taking place. The moisture content in this zone is above field capacity but below saturation. Further, it is characterized by unsaturated flow and fairly uniform moisture content. Now what is taking place here is the unsaturated flow. So if you study, maybe we'll study about unsaturated and saturated flows under groundwater hydrology. There's a topic to be taught to you. I believe I can teach you this time around. And under that, we will be talking about saturated flows and unsaturated flows. Now, what is taking place in this transmission zone is unsaturated flow. Now, this transition flow zone, in the transition zone, the flow transits from saturated flow to unsaturated flow. That is what is happening. Now, when it comes to zone 4, if you read the description for zone 4, the last zone is the wetting zone. The soil moisture in this zone will be at or near field capacity, and the moisture content decreases with the depth. The boundary of this wetting zone is the wetting front, where the sharp discontinuity exists between the newly wet zone and the original moisture content of the soil. Now, somewhere around here, there will be the field capacity, and below field capacity also exists, and the wetting front created in this zone. Now, let us talk about the concept of infiltration capacity. Now, infiltration capacity is defined as the maximum rate at which a given soil at a given time can absorb water, is defined as the infiltration capacity. Now, if you think about the infiltration capacity as FP and infiltration as F and the intensity of rainfall as I, now if you look at these two conceptual diagrams, on the left hand side you have low intensity rainfall, and at the right hand side you have high intensity rainfall replication. Now what happened is that if the infiltration flow taking place into the ground is higher than the intensity of rainfall, there won't be overflow of this bucket, right? Which represents the soil surface. So there is a certain amount of water retained in the soil, and on the left hand side there is no flow taking place from the second basket to the third basket. Now on the right hand side you can see that the second basket is also overflown by the continuous flow coming from the infiltration, and it will go to the third basket, which represents the groundwater flow. Now in the soil also this is what is happening. If you don't get enough rainfall intensity, it will be absorbed by the soil. No runoff will be taking place and it will be retained by the soil. But if you get excess amount of rainfall, only surface runoff and groundwater percolation will take place. So this is what it represents here. The infiltration capacity of an area is dependent on a large number of factors. Main ones are characteristics of soil, condition of soil surface, vegetation cover, and current moisture content of soil. You can read these things from your course material. Now, let us briefly talk about factors affecting the infiltration. Now, the infiltration capacity of an area is dependent on a large number of factors. Chiefly of them are characteristics of soil, and you can see how the infiltration capacity varies with the time in different types of soil. So wet clay loam has very low infiltration capacity because they are already saturated. Then dry clay loam has a better, higher infiltration capacity. And if you compare the sandy loam with wet sand loam to dry sandy loam, also dry sandy loam has a better infiltration capacity because it has enough pores, enough extra pores, enough additional pores to absorb water. Now let us briefly talk about measurement of infiltration. Infiltration characteristics of a soil at a given location can be estimated by using these four methods. Using flooding type infiltrometer. Sorry. Then measurement of subsidence of free water in a large basin or a pond. The fourth one is the rainfall simulator. The third one is the rainfall simulator. The fourth one is the hydrograph analysis. Now let us first talk about using flooding type infiltrometer. I believe you have been introduced to these things during your O levels and A levels, and it's if you read it out these lines, flooding type infiltrometers are experimental devices used to obtain data relating to variation of infiltration capacity with time. Two types of flooding type infiltrometers are in common use. They are tube type or simple infiltrometer and double ring infiltrometer. So this is a single ring infiltrometer, a simple one, a double ring infiltrometer. Now, please read the note on different types of infiltrometer, and this is a small problem for you. You can discuss this. Please discuss the differences between two types of infiltrometer. Why these two types are introduced? what are the advantages and disadvantages there are in these two types of infiltrometers. Now, the other method is to use the rainfall simulator. I have got this from my internet. In this, a small plot of land of about 2 meter to 4 meter size, you can see 4 meter to 2 meter size, is provided with a series of nozzles on the longer side with arrangements to collect and measure the surface runoff rate. So what you do is to provide an artificial rainfall on this plot of land, and they measure the runoff of the water. Then also they collect the overflow water. So with that, they can calculate the infiltration balance. Using the water budget equation involving the volume of rainfall, infiltration and runoff, the infiltration rate and its variation with the time are estimated. Well, the measurement of infiltration continues. The other method is to measurement of subsidence of free water in a large basin or a pond. So you can imagine a uniform large pond or a basin. The water loss from the large basin or a pond created on flat ground is measured over the time to determine the water infiltration. So you can measure the water loss with the decrease in depth, so that you can calculate the infiltration. Then the other method is to do the hydrograph analysis. You can make a reasonable estimation for this infiltration using hydrograph analysis, and we will be talking about hydrographs in the session 5. Then we are going to talk about modeling infiltration capacity. I mean, it is not practical to do the infiltration measurements all the time, but it is better to do the modeling to obtain the infiltration capacity. The figure shows a typical variation of infiltration capacity FP with time. The cumulative infiltration capacity capital FP is defined as the accumulation of infiltration volume over a time period since the start of the process and is given by this equation. Now, it is generally what you do is to measure the cumulative infiltration capacity. If maybe you are using a infiltrometer, you can just measure the continuous depth of water. So it will continuously increase, right? But if you take the differentiation, derivative of this curve, it will give you the infiltration capacity. And at a certain point, it will come to a constant value. And this constant value is given a special name. It is called steady state infiltration capacity. Now, until this steady state infiltration capacity FC reached, we cannot determine an infiltration capacity for calculation because it is continuously fluctuating. So we have to get this FC value to do proper calculation. Now, one model is proposed by Horton in 1933. It is called Horton's equation. So now this is there in your course material. It says FP equals FC plus F naught minus FC into e to the power kh time t. Now here FP is the current infiltration capacity at a given time. F naught is the initial infiltration capacity at t equals naught. FC is the final steady state infiltration capacity occurring at T equals Tc, which I have just shown before. Now this Kh is given a special name and it is called Horton decay coefficient, which depends upon soil characteristics and vegetation cover. Also, Fc is sometimes known as constant rate or ultimate infiltration capacity. This is also known as constant rate or ultimate infiltration capacity. Now you know that this equation represents the Horton model, but you need to determine a certain parameters. Now to determine certain parameters, we have to use this experimental modeling. Now you have to take the logarithms on the both sides, so it will become a linear equation. You can see if you take logarithm, it becomes a linear equation. Now this component becomes a constant, kh is a constant, so it is a plot of ln fp minus fc versus t. So in that plot, you can find the intercept and the gradient. The intercept will represent kh, and the intercept, the gradient represent kh, and the intercept represent ln f naught minus fc. And you have other types of infiltration models quite similar to this Horton model. You can read it out from the book, and the determination of the parameters for these models are quite similar to each other. You can see it in your course material. Now let us briefly talk about this example. This example there in your book. It says infiltration capacity data obtained in a flooding type infiltration test is given below. For this data, plot the curves of infiltration capacity versus time, infiltration capacity versus cumulative infiltration, and the cumulative infiltration versus time. So you can derive anything out of this set of data. So what you do is to get the incremental depth of infiltration, divide by the time, so you get the infiltration rate, so you can do the rest of the calculations, right? Now this, you can see infiltration comes to a certain constant value, it goes down continuously, come to a constant value, and you can consider this to be the FC, or the constant rate infiltration. And you can calculate the FP if you know FC, and you can find the log value of that, and you can plot it against time. So you can get all these curves once you have done this calculation. It is not that difficult. Now with this curve, you can easily find the gradient as well as the intercept. Now with that, you can find the relevant parameters for your model. So finally, we are coming to the final part of the session 4. Now, there is a concept called infiltration indices. Now, in these indices, what we do is to give a certain value to the infiltration loss, and you can find out the remainder, or the effective rainfall, what we call, which generates the runoff from the catchment. Now, if you read it out, in hydrological calculations involved in floods, it is found convenient to use a constant value of infiltration rate for the duration of the storm. The defined average infiltration rate is called infiltration index. Now, over catchment, the infiltration rate could vary, right? It could go up, it could go down, but you can't do calculations with such variations. So instead of that, we define a certain parameter called phi index to represent the infiltration, and we do rest of the calculation. Now let us briefly talk, read about this phi index. Now this says I have got it directly from your course material. The phi index is the average rainfall above which the rainfall volume is equal to the runoff volume. The phi index is derived from the rainfall hydrograph with a knowledge of the resulting runoff volume. The initial loss is also considered as infiltration. The phi value is found by treating it as a constant infiltration capacity. If the rainfall intensity is less than phi value, then the infiltration rate is equal to the rainfall intensity. If it is greater than, only you have a runoff. Now, to determine these steps are there, assume that out of given n pulses, let me go to the note directly. Now, can you see this word file? Hello? Can you see this word file? Hello?
Yes,
Can you
sir.
hear me?
Yes, sir. Yes, sir.
Okay, thank you. Now, now this is in your course material. So what we do is to now if you get the rainfall intensity variation with hours, let's say first 2 hours you might get a rainfall intensity of 0.5 centimeters per hour. Likewise, you can draw this bar chart graph. Now if the losses are beyond, you can define the losses to a certain intensity of rainfall. So whatever the rainfall that is below this value will not result in a runoff from a catchment. So that is what we call phi index. Now, in order to determine this phi index, these steps are proposed. Now, these 3 steps are proposed. First, assume that out of given n pulses, let's say you have number of pulses here n pulses, n number of pulses have rainfall excess. Now, you can assume a certain number of pulses have excess rainfall, more than phi index. Select m number of pulses in decreasing order of rainfall intensity. If you have a set of data, you have to select the most highest m number of intensified rainfalls or periods. Then find the value of phi that satisfies the relationship this. Now what is this? RD equals sigma I, capital I, simple I into delta T minus phi delta T. What is this? Now if you go to this graph, I into delta T means if you take one bar like this, one tower like this entire thing. Okay, this entire thing. Now phi into delta T represents by this is H area. So the remaining area is what you call RD. So that is what this represents. Now, in order to find the area remain for all these towers, you have to do that exercise for all these towers, right? So you will have an equation like this. Using this, you can calculate the phi index for the assumed m number of pulses. Then in the third step, then you can calculate how many pulses are greater than the calculated phi index. Let's say you have decided m number of pulses are greater than the phi index, but if the calculated values are, let's say, m plus 2, your assumed phi index is wrong, right? Then after that, in the third step, if the number of pulses which are greater than the phi index is equal to m, then the calculated phi in the step 2 is correct phi index. If not, you will have to repeat the step 1 with another assumed value of pulses. Now, this example is a great example, example 4.4. To understand this concept, what you need to do is to calculate the incremental rainfall and the intensity of rainfall during that particular time period. I think you can understand it by yourself. So the time period delta T is 2 hours, time period is 8 hours, the interval is 2 hours, total number of pulses are 8, and you can do the trial first. You can assume m to be 8. That means all the pulses are greater than phi index, and you can do the calculation and see the value for phi index. So what you have got here is 0.263 centimeters per hour. Now, if you go here, you can see after there are certain values which are below than that value. That means your assumption is wrong. So you do the trials 2, assuming that m to be 7. So you can do the calculation and calculate the phi, and you have got a value called 0.271, and you can see there are pulses which are, the number of pulses are not the same. You can see here trial 2, number of pulses are not correct. It is 6. So the trial 2 is also not working. So you go for trial 3. You assume number of pulses which are greater than the phi value to be 6. And you do the calculation, you get the phi value. And by inspecting the table here, you can find there are 5 pulses which are greater than this calculated phi value, 0.275. So your assumption m equals 6 is correct. So your phi index is also 0.275, which is corresponding to the correct assumption. That is how we do the calculation for phi index. Now for W index, so what you simply do is introduce the infiltration, initial losses into the equation. That is all what we do instead of other than in phi index calculation, in an attempt to refine the phi index. The initial losses are separated from the total abstractions, and an average value of infiltration rate called W phi index is defined. So we only introduce phi index, and this describes the method to calculate the phi index to compute, the method to compute W index To compute W index from a given storm hydrograph with a norm value of IA, that's initial loss, and the runoff R, the following procedure is followed. Deduct the initial loss from the storm hydrograph pulses starting from the first pulse. Now, if you go to this previous calculation in this table, you only have to introduce another row which represents a value to initial losses. You only have to deduct it from this incremental rainfall and you can calculate the intensity. Then after that, rest of the calculation is quite similar to phi index. There's nothing much different, right? Use the result hydrograph pulse diagram. Thus, the procedure is exactly the same as in the determination of phi index, except for the fact that the storm hydrograph is appropriately modified by deducting IA. That's all. So, with that, I will wrap up the today's day school, and I am planning to conduct another day school next week, most probably Tuesday. Shall we do it on Tuesday? I wanted to do session 4 and session 5 for day cat 1. Then after that I will continue with session 1, 2, 3. Then I will move into block 2. What do you say? So you will be getting CAT exam from session 4 and session 5. I'll be doing a day school for session 5 as well in the next week. Okay. I'll be doing MCQ exam. I will conduct an MCQ exam for you. Okay. Do you have any more questions?
The CAT 1 is online, no?
Online, yes. Didn't they inform you about these things? Examination? Did you receive the timetables? Can somebody speak and let me know? Irandati, are you there, Irandati?
Yes, sir.
Did you receive the timetable?
Yes, sir.
So when do you have CAT 1 for hydrology? I think somewhere in 17 or 18. Yeah, unfortunately, you are going to face it during night, okay? Now, I don't know.
19th.
Sorry?
19th.
19th.
Yes.
Now, the thing is this. Now, the server, our server, what IT says is that these are the time periods available to conduct the CAT exam without power cuts. So that is why they have defined these time periods. But the problem is you might experience power cuts from there is one slot from 9 to I think 10:15. During that, some of you can experience power cuts during that time. We don't know the power situation in the country. We don't control the power situation in the country, power supply. So I advise most of you to have certain backup power for your examination, right? Try to find some sort of backup power for routers or to maintain the internet connection for your examination. Okay, that is all I can tell you. Unfortunately, due to this severe situation, we can't conduct physical exams. Okay. I will upload this. I think I have uploaded the session 4 into the Learn USL. Did you receive the session I cannot issue you the blocks. What I can issue is the lessons material. Well, maintaining a proper internet connection, I can't help you with that. You will have to find a way to maintain your proper internet connection because this is examining, right? Session 5 is there, session 4 is there. Incredible. Okay, what I will do, I will just upload session 4 into this. Okay. As well. Okay, I have just uploaded the session 4 into learning resources of Learno USL. Somebody has asked, can we join the exam by the phone too? I am not aware about that. I don't know how the technology works, whether it supports to face the exam through phones. I do not recommend to use a phone to sit for online exam. That's from my side. Okay, you have to contact the IT and these people and ask. I don't know what they are doing with your course materials also. We have told them several times to issue these things. I would like to know, I just wanted to get a statistics. Now, I am supposed to have 300 students for this course, but only around 55 persons are there. Can you please raise the hand digitally who have not got the course materials? So far, it's about 13 persons out of these 54. Okay. Now, I have uploaded the relevant sessions in the learning resources, under learning resources of Learn How Yourself. You can download them and study yourself. That's all I can do from my side. Okay. Okay, I will do a separate day school on somebody has asked a question whether the questions are sequential or non-sequential. What do you mean by that? What do you mean by non-sequential questions? I will create a question bank and you will get a set of questions from that question bank. So one might get a different set of questions than others. Sometimes you may get the same questions because it is randomly taking place. Okay. Okay, thank you very much. If you don't have any more questions, I will wind it up. Okay. Please go through the course materials and the given digital materials if you don't have course materials thoroughly. Okay. And I have to conduct a practical also for you in the in this course. We'll see how we can do it. Okay. Right. Okay, then thank you very much.
Thank you very much, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.